Okay. Now, how about if the factor decreased below the norm? Take an example of sugar levels. They may increase or they may decrease. Now, if a factor to be regulated decreases below the norm, decreases below the reference point, that deficiency again is detected by the detector or the receptor. Now, once the detector or the receptor notices that there is a decrease in that factor, it is below the norm, what happens? It again sends information to the controller, control center, coordinator, informing it that the factor is in deficiency. It is below the norm. Now, the controller then sends information to the effector. Remember, corrective information to the effector, so that the effector now sets into action corrective measures, corrective mechanisms to increase that factor back to the normal. When it is increased back to the normal, again, that is negative feedback, because negative feedback is restoration of a system to its original state. Where is the original state? The norm. After disturbance, it has decreased below the norm. That is the disturbance. So it is now increased back to the norm. Hence, negative feedback. That's bringing about homeostasis. But what if mechanisms come in to decrease that factor the more? It is not increased back to the norm, but mechanisms decrease it the more. Then that is positive feedback. And being positive feedback, remember we've seen that it would not be homeostasis, because homeostasis, it should be maintained constant. So in our part of homeostasis, we are basically looking at the norm, factor increases in excess, detected, information sent to the control center to the effector, brings in corrective mechanisms to decrease it back to the norm, negative feedback. A factor decreases below the normal, detected by the detector or receptor, informs the coordinator or the control center, sets into action measures that would correct, information sent to the effector now brings in the corrective mechanism, factor increased back to the norm. Then that is the principle of negative feedback. That is why we said that among the components of a homeostatic system, there must be a detector, there must be a control center or controller, there must be an effector, like we've seen, there must be a reference point, which is the norm, and there must be a feedback loop. And we've seen that all apply or function using the principle of negative feedback mechanism. Now, after noting what those are, we now move on and look at the properties or the characteristics of a homeostatic system. What we should have in the mind now, when we talk of homeostatic system, we are talking of a factor deviating whether up or down, but afterwards it must be brought back to the normal, which normal we are calling the norm. So what are the properties or characteristics of that system, of that homeostatic system that should function to keep the internal environment constant? One, we are saying that the homeostatic system is self-adjusting. Self-adjusting. What do we mean when we say it is self-adjusting? The homeostatic mechanism is triggered by the level of the substance itself. What do we mean? If we are looking at regulation of sugar levels, sugar levels that should be maintained at a constant, it means that the homeostatic mechanism to keep the sugar levels constant is triggered by the level of the sugars themselves. If we are looking at regulating the temperature to keep the temperature constant, the homeostatic mechanism to keep the temperature constant is triggered by the heat of the body itself. If we are looking at carbon dioxide levels, we want to maintain the carbon dioxide levels constant in the body. It therefore means that that mechanism of maintaining the carbon dioxide levels constant is triggered by carbon dioxide itself. Therefore, the factor which is to be maintained constant is the very factor that triggers the homeostatic mechanism. In other words, it adjusts itself. The homeostatic system is self-adjusting. It is triggered, the mechanism is triggered by that very factor. You want to regulate carbon dioxide levels, then it is carbon dioxide itself to trigger. The body wants to regulate the water levels to maintain the osmotic pressure constant, then it is the water level itself to trigger any change. The body wants to maintain a constant temperature of blood, then it is the temperature itself of blood to trigger. Therefore, it is self-adjusting. The second characteristic, it involves the principle of negative feedback. The principle of negative feedback. What do we mean when we say it involves the principle of negative feedback? Remember, from what we have seen, that any deviation of a factor from the norm triggers corrective mechanisms to bring it back to the norm. Whether the factor increased or whether the factor decreased, it triggers corrective mechanisms to bring it back to the norm. That is what we mean by negative feedback. Therefore, we cannot have homeostasis if there is no negative feedback, if there is no restoration of a system to its original state after disturbance. Whenever a system is disturbed, it must be restored to its original state after disturbance. And that is what we are calling negative feedback. Therefore, it involves the principle of negative feedback. Just like we have seen there in that scheme. Whether it is in excess or in deficiency, the corrective measures either decrease it back to the norm or increase it back to the norm. That is what we've called negative feedback. The other property or characteristic, it works on fluctuations of the normal levels of the substance. It works upon the fluctuations of the normal levels. What do we mean? Remember, we've talked about the norm. The norm, also called the reference point. So for a homeostatic mechanisms to work well, it works upon the fluctuations in the normal levels. Should the sugar levels fluctuate above or below the norm, then the mechanisms will work to bring it back to the norm. Should the salt levels in blood fluctuate, changes will occur to bring it back to the norm. Therefore, the homeostatic mechanism works upon the fluctuations for it to work effectively. What is it going to work on or upon? It is working upon the fluctuations, so that it brings them back to the norm, or back to the normal, or back to the set point, or back to the reference point. Then, the homeostatic system, for it to work, Remember, it cannot work without the components. Which components? We talked of the detector, we've talked of the regulator or control center, we've talked of the effectors. Meaning, for the homeostatic system to function, what does it rely on? It relies on the detector, it relies on the regulator or controller, it relies on the effector. Because those three are the ones important in bringing about the negative feedback, and in turn will bring about the feedback loop. Meaning, homeostasis cannot occur. It can't occur if there is no detector, if there is no regulator, if there is no effector. That is why we say that it relies on receptors to do what? To detect the changes. It relies on the regulator to do what? To initiate corrective mechanism. Corrective mechanism. It relies on effectors to do what? To bring about the corrective mechanism, to bring the corrective mechanism into action so that the factor is regulated or taken back to the norm. Therefore, so far, we have seen what homeostasis is. We have seen what should be kept constant. We have seen the components of a homeostatic system. We have seen the properties or characteristics of a homeostatic system. Meaning, how does a homeostatic system work? How does it work? How does it function? This scheme is summarizing how it works. Meaning, we cannot talk about how it works without talking about the components of the homeostatic system. And these components relate with each other, just like we have seen and summarized it in the properties of characteristics of a homeostatic system. But remember, what should be kept constant? Blood and tissue fluid concentration. This now brings us to tissue